Welcome to the 1.3 instructional video. And really what we're going to be talking about in 1.3 is all of the transformations together. So typically, and I'd like to start with this with the idea that we will be given one function, so y equals f of x. We don't know what f of x is. It could be a bunch of different functions. And then what we're going to do is we're going to identify g of x as the transform function, and we're going to apply a, b, h, and k. Now, immediately that looks a little bit uglier, and we'll practice some of, actually putting this into a function, which takes a little bit of practice. But I think right off the bat, it's useful to talk about how to actually take points from f of x and find the points on g of x. And I really do think that's more than half the battle. So a point on f of x, I'm just going to label in a general way, x comma y. And then when I apply this form of transformations, what that becomes is 1 over bx plus h comma ay plus k, and we'll apply that specifically to questions as we go beyond. I'm just going to make my b look a little bit more like a b. What is important is that none of the stuff that we've talked about in 1.2 and 1.1 has changed. So we still have a vertical stretch by the absolute value of a, and then if a is less than 0, we reflect over the x-axis. We have a horizontal stretch by 1 over the absolute value of b. If b is less than 0, we reflect over the y-axis. And then h and k are in there as well. So we're going to have a horizontal translation, h units. And I always like writing this in that if h is greater than 0, we go to the right. If h is less than 0, we go to the left. And then last but not least, although typically done last, is the vertical translation by k units. And if k is greater than 0, we go up. And if k is less than 0, we go down. All right, now I would like just to do this with one specific function, and then we'll get into the examples from 1.3 and do it really a couple more times as well. So as an example, let's say that we were told that f of x, and we'll do a simpler function for sure, just x squared. I'd actually like 2 x's in there. So x squared plus 3x. And then what it tells us is that some new transform function g of x is going to be 3 times function f evaluated at 2 times x plus 1, and then finally minus 5. Now, what's really important about this is that f at 2x plus 1 means that this statement, or this expression, 2 times x plus 1, needs to be substituted into both of those variables. And that's a really important consideration. Often students will do one and forget the other, and then the whole thing kind of falls apart. But what we can do now is we can actually come up with the equation of g of x. So I'm going to use some square brackets up here around the function itself, which means that I would be multiplying the function by 3, and then also after everything is inside, subtract 5 from it. So really importantly, that this is 3 times f of x, which will be right here, except it's no longer f of x. It's f evaluated at 2 times x plus 1. I'm just going to get rid of those red arrows so we can see that. Now, f evaluated at 2x, or 2 times x plus 1, is function f with 2 times x plus 1 being substituted into all of the x variables in there. So in a bracket, we would have 2 times x plus 1 squared plus 3 times 2 times x plus 1. Now, brackets are very much your friend in doing this, but what is important about what we just did is now what we could do is grab a calculator, look at f of x being y1, look at g of x being y2, and then we could use our trace function and a few other tools to kind of confirm that we've done the mapping correctly. Speaking of mapping, I'd like to identify that below. So what I just did was I used a is 3, b is 2, h is -1, and k is -5. Just want to take a second that the reason h is -1 is that in that function notation, f of 2 times x plus 1, I could write this, and I should write this, as f of 2 times x minus -1. And the reason that we want to do that is because the transformation general form is b times x minus h. Very, very important that that negative is there. So we are subtracting -1 in this context. Now, what that allows me to do is I could describe this in words, but I want to focus on the mapping here, is that we would have x comma y turning into, and I want to take this piece by piece. If you have, hopefully you've written down that first page, you can take a look. Then I'm going to do exactly what I did in that instructional piece, except with a being 3, b being 2, h is -1, and k is -5. And what a point x comma y becomes would be 1 over 2x minus 1 comma 3y minus 5. And just to reiterate that one last time before we get to the examples, this is a point on the original f of x. And when I evaluate that, that would give me a point on g of x. Okay, make sure you do watch those example videos where we get into some of the meat and potatoes of this as well.